Welcome back to another week of meteorological tips for young meteorologists. I wanted to touch on something that really drives me nuts when I see a lot of even meteorologists use this tactic, more so to drive up interest than to actually make a forecast. But it can really be misleading to the general public that doesn't know any better. Of course, I'm talking about snow maps. Now, snow maps have a place, okay? They really do, okay? They can help you give you a range of where your snow forecast can be. It can give you a general idea of possibly where some of the model guidance is picking up some mesoscale banding when you're making a forecast, and give you a general idea of where potentially the heaviest snowfall can be. But you never, ever want to use it as a basis of your forecast. You want to use things like your lifting parameters, like where your PVA is forming, upper level load development, QPF amount, how much moisture is available in the atmosphere, a whole host of things. But let me explain to you, rather than berate you, say just don't do it, let me explain to you the pitfalls of some of these model solutions, these graphics. So first of all, let's look at the European Ensemble Guidance 15-day forecast I saw floating around that a lot of people were posting. Some of them meteorologists who really should know better. Okay, now when you're using this, you have to understand a couple of things. First of all, the 10-to-1 ratio. Especially in the spring, if you're going to use a standard 10-to-1 ratio for your forecast, you're going to end up with a lot of trouble, okay? Because you have a higher sun angle, you have different rates of the type of snow ratio in the atmosphere, and even in the dead of winter, you could have some locations that are 20-to-1, some locations that have mixing, and some of the model parameters don't factor that in. Some do. But do you understand which one does? And do you understand that some of the graphical presentation that you see there is more about getting clicks, getting social media clicks, likes, follows, and clicking on the URL of the social media link than it is about displaying an actual forecast. Model snow maps usually lack a lot of the finer details that you need when you're making a forecast for snowfall. And also, in the case of an ensemble snowfall map, a lot of them, remember, this is anywhere between 30 to 50 different models being averaged out. So if you get one or two that are absolutely bonkers that you know are wrong, you can easily end up with this solution. Now, there are times when it's good to use a snow map. Okay, I'll give you an example. If you're using the ensemble forecast and you're using 15 days, and you want to kind of get an idea of if the pattern is favorable, and if you have the high latitude blocking in place already, and you know where your ridge axis is, in other words, the pattern itself is favorable for snowfall, then you can turn around and use that map to get a general idea of the various model ensembles, okay, and look at them and see how many of them support an accumulating snowfall. Then you can take that and say, okay, the potential for accumulating snowfall is high. And by taking that data, then you could go tell your client that, hey, look, you should be prepared for an active winter pattern. I don't know how much, but it looks like an active winter pattern, and you should be prepared for it. Now, let's flip that, and now let's just put ourselves in a situation like what we are in now, where the pattern is unfavorable. If you see this, the first thing you should say is, okay, which model suite really went off the rails? Because this is not going to happen, because you understand what is capable in the pattern that you are in. No matter how much you want to wish it, or you want to have a fantasy about it, which is really weird, but it's not realistic. So if you want to gain credibility, and you want to have people respect what you do, the first thing you should never, ever, ever do is post a snow map from a model, from any model, without specific explanation of what you're showing. And even then, you could say, here's a good way of saying it. You could say, hey, look, the HR Argines, which is a mesoscale model, is showing this impressive mesoscale banding, this heavy snow band that's showing up. It may not be accurate, but this gives us the potential of what this snow band can do. So what you're doing, you're explaining to your client or the general public, hey, this might not be 100% accurate, but it also explains to the person that's watching you or reading your content that this is what the potential should be, and this is what you need to prepare for. Stating that, even in those situations, you only want to do it when you know that the overall pattern or the overall storm environment would support even remotely that situation. In other words, you don't want to use that when you know it's going to be 45 degrees and raining. Unless you're talking about flash flooding and the potential for heavy rainfall and what that potential of a heavy rain band can be. See, what you want to do, I guess it comes down to this. You want to use it as an illustration point, a graphical illustration point that the public will understand, but it is in a situation where that potential is a reasonable explanation based on all the other data that you have. And that, ladies and gentlemen, is your tip for this week. I hope you use it well. And for God's sake, stop posting the 350 plus hour GFS snow map. If any of those things were ever accurate, I'd be super rich, which I'm not. So there's no point posting them. Please, for the life of God, please stop posting them. They're going to be wrong, and you're just going to be disappointed. Have a wonderful day. And as always, stay safe out there.